All right, the start of the recording. All right, is everyone watching my stream? All right. So for assignment 9, the assignment involves the whole assignment is based around making a linked list class. And for you to understand how to do this assignment properly, I need to explain linked lists. A linked list is a data structure. It's similar to an array in that it's pieces of data in a sequence, but its structure is very, very different. So with an array, it usually has a set size, and whether you use new or declare an array statically, the array size never changes. Linked lists are different though. Linked lists grow bigger as more data is added to them, and they shrink when data is taken away from a linked list. And the way that linked lists do this is by carrying a pointer to the next link in the list. So if an array can be seen as several blocks all right next to each other, this whole block being one static thing, a linked list can be seen like this. So you've got the actual value, the thing being held, and you have a pointer to the next link. And at the end of the list, you know you hit the end of the list when the final link is just the null. Usually linked lists will have a head pointer and a tail pointer. Since linked lists usually only carry a pointer to the next link, the head pointer is usually used to access the list because it points to the first link, which has access to every other link. But tail is still important. Linked lists involve a lot of pointer arithmetic, especially for a first-time computer science student. So before I start showing any code, before I even go over the assignment, I'm going to draw physical, visual examples of adding data to a linked list. So the linked list starts out head and tail are both null, because the linked list starts with no information. So let's say we want to add 3. Also, you specify there's 2 ways to add to a linked list. for this assignment, I'm going to be going over both of them. You can add to the head or you can add to the tail. Use add front and add back. Let's do add front 5. Now, if the head and tail are null, then it doesn't matter if you're adding to the front or adding to the back. The algorithm is the same. If both head and tail are null, no matter where you're adding, you want to create a new node in the linked list. Using the new operator. You add the value in, set its link to null, and then make head and tail both point to the link. So head and tail now both point to the same link. Now let's once again add 5. Let's add another number. Let's add 13 to the beginning. All right. So you want to add 13 to the beginning, meaning we want 13 to be here. I'm going to move this here so that the list can grow in both directions. So we have this list. It has one item, and we want to add 13 to the beginning. So we create a new link. If you're adding to the beginning, you create a new link. You set the value, and then you set the next pointer to the next link to the head. Then you set the head to instead point to the link that you just allocated. All right. Now let's add to the back. So we're going to add to the back end 8. So you're adding to the back. You create a new link. You set the value to whatever the past value is. And then you want to set the next link to null. The tail should always hold null as the last value as divided that it points to, because null lets us know that we are at the end of the list. And so when you create the new link, you change it so that you keep tail pointing to its current node. You make the tail node point to the node that you just added. And then you make the tail itself point to the new tail. Does everyone understand so far? Do you need me to explain it differently? Or do you need me to... Just any questions that you have.
So the link points to the next list, is that Is that what it is? For
So
the link?
each link points to the next link. So this in code, this might be like int a, and because a linked list, each of these is a struct of some type. It might be like node type, like asterisk next. So this would be so this is an example of what a definition of a linked list type might look like. So the struct is called node type. It's a custom data structure. And the link to the next is a pointer that is of the same type as the struct itself. Does that answer your question?
Yeah, it does. Thank you.
All right. So doing a delete from a linked list is also something pretty complicated to go over. So let me make an imaginary list. All right, so there are three cases for having to delete a node. And the cases are that the node is at the head, the node is at the tail, or the node is somewhere in the middle. So going for deleting a head node, we'll imagine the function is called del node. Say we want to delete 5. All right, well, 5, you have some kind of temporary pointer. And we start off by pointing it at the head. So if the head is the node to be deleted, the method is you take the head and you make it point to its next node. And then, using the temporary pointer, you delete this. So you delete this, so this gets erased. All right. Now let's say that the node is at the tail. So if the node is at the tail, what you want to do is make the tail point to its previous node and then delete the tail. But the nodes don't go back. Nodes don't know what the last node behind them is. So you start by making the pointer point to the head, and then we make the pointer travel down the list. We keep checking. All right. Is this pointing to the tail? All right, no. All right, now is this one pointing to the tail? Yes, this one points to the tail.
How would we know if it points to the tail?
So head and tail would be specific pointers that you would have in the linked list class. So the class itself would have a head and a tail that would both be pointers to the head and the tail. So you would literally say, like, pointer
temp equals tail,
like pointer like next equals tail. And this would say if the pointer, the next node is the tail, because you would literally hold this pointer in the class. Does that answer the question?
Yes, thank you.
All right. So when you finally have the second to last node, you take the tail pointer and you delete it. You just delete, you delete the tail pointer. Then you make the tail pointer point to the temporary pointer that was being used to traverse the list. And then finally you make the tail next pointer point to null. Because the tail does not point to anything else. It's the end of the list. Now, finally, we have the example of the node is somewhere in the middle of the list. So if the node is not the head and it's not the tail, then you need to traverse the list until you find it. Start out, all right. Start at the head. And you want to check, is the next list, you want to check not the current link, you want to check if the next link is the node that you want to delete. And the reason why is to delete a link, what you do is you cut it out, or not exactly. So when you find the link you want to delete, you want to hold it in a temporary pointer. Make a temporary pointer just for that link. Then you take the link before it and you instead make it point to the link after it. So you're taking this and you're removing it from the chain by making its last link point to the link after it. And then you delete this link. You delete the temp.
So when we're deleting links or modifying this list, we delete the pointer and then we delete the data and then we modify the pointer, right?
You delete the pointer the same way you would use delete anytime, because these are all going to be pointers. these are all going to be allocated using new. And they're all going to be deleted using delete.
Okay, gotcha.
This assignment will have a lot of pointer arithmetic, which I will try. I explained to the best of my ability how to avoid memory leaks. Now I'm going to run the assignment. All right. Can everyone see? Well, I'm not literally running the assignment. I've made a linked list class that I'm not going to show you because you have to make the linked list class yourself. But I made my own linked list class that does some of the things that the assignment requires you to do. So this linked list class has special functions that I wrote. These are different from the assignment. I wrote these functions to accentuate, like really exaggerate how linked lists work in code. So this is code. Creates two linked lists. And it then propagates them by adding to the front of one and adding to the back of the other. Then prints the lists. And then it deletes all of the even numbered nodes. Then prints the list again and then shows the head and tail of list 1 and 2, the head of list 1 and 2, and then the tail of list 1 and 2. So when it prints both lists, I made it coded it to print to exaggerate what a linked list is. So each link held the value inside the actual literal value, and then a pointer to the next link in the list. So the first link is 9, and it points to the next link, 8. Points to the link after that, 7. 7 points to 6. 6 points to 5. 5 points to 4. 4 points to 3. 3 points to 2. 2 points to 1. 1 points to 0. And 0 points to nothing. It points to null, telling us that we've gotten to the end of the list. And the other list is the exact opposite, just counting up. So with the even numbers removed, the list has shortened. It's gone down by half because 0 and all the even numbers have been removed. So the actual list itself changed sizes when we remove data from it. And because we have a pointer to the head and the tail, getting the head and tail values are as easy as just getting the value located at that pointer. So by just simply calling the head and the tail, we can get the head and tail values. Does everyone understand so far? All right. I'm going to go back to the slides. And we're going to talk about the constructors. So with the regular constructor, you want to set first and last to null and set count to 0. So first and last are the pointers for the head and tail. First points to the beginning, last points to the end. And we first create a linked list class. The list is empty. There's nothing inside of it. And the count, which is a variable that is used to hold how many links are in the list, will be set to 0. And as you add and delete things from the list, you have to increment count and decrement count whenever something is added or deleted. So in the copy constructor, which is when the constructor is given another linked list to copy, You want to do the same as before, only you want to set the count to the count of the list that's being passed. And then if the list that has been passed is not empty, then you want to copy the list. Because you want to copy all the data inside the list that was passed to the list of the class. And for linked list type, the destructor, and for initialize list, you want to do the same thing, just call destroy list. Everyone understand these constructors and destructors so far? All right, and these functions are very, very simple. For is empty, if first equals null, then the list is empty. Because if the link is null, there's nothing in the list. So just return true if first is null. Else return false. So as long as it's not null, there's at least something inside the list. For print, you need to print each node in the list. Then you need to format it by printing just the info in the link and a space. To traverse a linked list, it's pretty simple. I've already shown you how to traverse an array. So in traversing a linked list, using a for loop, the first two conditions are very similar to how it is when I showed you how to traverse an array using pointers. Only difference is when you increment it, you don't increment the pointer by a certain amount. You make the pointer equal the link of the current node. This is just a general case for how to traverse a linked list. Does everyone understand this so far?
I just wanted to make sure if I was understanding the print function. We're going through each link to get that info from that link.
You are printing it to the screen, is what you're doing.
Right. Mm-hmm. Okay. Thank you.
All right. For reverse print, you want to call the recursive reverse print function. And for length, you just return the count. So this function is relatively simple. Now for destroy list, if first is null, return. Because if first is null, there's no list to destroy. List is already destroyed. So when you destroy the list, you want to use a temp pointer. So destroying the list is going to look like this. So you want to get some kind of temp pointer. And you want to use temp to hold the next pointer. So temp should equal first the link of the first pointer. And on a loop, what you want to do is set temp to the link of the first pointer, then delete first. And then set first to temp so that first now points to the next node. And then you want to repeat while first is not equal to last. So you repeat, you set temp to now point to the link after first. And then you delete first. So delete this. And then make first point to temp. And you check first is still not equal to last. So you repeat. So you set temp equal to first link, and then you delete first. And then set first to temp. All right, now we check is first equal to last. All right, well, it is equal to last. So now that it's equal to last, the loop is ended, and we use the final step, which is delete first. So delete this. Delete this. Delete the final link. Then take first and last. After you deleted the final link, set first and last both to null. So they both point to null. And set count to 0. Does everyone understand so far, or do you have any questions? All right. So the function first PTR returns the literal location of the first pointer. And the function front returns the value held by the first pointer. So it returns the actual info held in the link. So back is the same as front, only it returns the info at the last node. Now for copy list, this is kind of complicated. So F first and last, and then we have some kind of list to copy. So the first thing you want to do is you want to set first to a new link. And you want to set its next link just equal to null. And you want to have two extra pointers that you use to traverse the lists. An original pointer to the original list and a pointer to the list that is being copied. And you start out by setting copy equal to first, so you can copy the list, and so that we don't move first down the list, because we want first to continue to point at the first list. And you set original to point at the new list, or the original list. So you start out before the loop by copying the info from the original node into the new node. And on a loop, what you want to do is you want to move original to point at the next link. And then if this new link is not null, you create a new link, move the copy down, then copy the data over from the original. And then you and then make sure that the new link points to null. Every time you make a new node, make sure that the new link points to null. Or you can do that after the loop. But the basic algorithm is make original point to the next node. If that node isn't null, then set copy's link to a new node. Change copy to point to the new link. Then copy the data over from original. And then make original point to the next node. Use the link of the copy to create a new node. Copy the data over. Set the link to null. And then when the original finally prints to null, when it's finally pointed to the end, then you stop the loop. And the next step that you do, this has made the last node point to null, is you take link. You want to start link at first. And you want to make link point to every node down the list until the link, meaning this, points to null. So we want last to stop here where the next node is null. Does everyone understand so far? All right. So for recursive reverse print, the base case is that the list, which is a node in the link, is null. So if it's null, then return it. Else, you want to print the next link, then print the current link. And of course, you would print the next link recursively. Now for the actual add and delete and search nodes or search functions, those are handled in the unordered and ordered linked list classes. So the linked list type, that class won't handle inserting or deleting nodes. That will be handled by the unordered and ordered linked list types, which will inherit and then implement these functions. So for search, it's relatively simple. Just iterate through each link in the list from first until a null pointer. If the current link holds the value that you're searching for, then return true. When the loop concludes, loop's over, return false, you haven't found anything. Insert, that's pretty easy. I want to create a new node. You want to create a new node. And then you want to set the node's link to first. Then you want to move first so that it points to the new node. Now for insert last, once again, relatively simple. You want to create a new node, and you want to set its link to null. And you want to make last point to this link with its next pointer, then make last point to the new pointer. Everyone understand this for an unordered linked list? All right. So delete is a little bit complicated. Let me use this space here. So if you're deleting, you want to check the node and you want to make sure that the node is in the list. So first you would check, all right, is the first pointer the one that has the node? Do we want to delete the first pointer? And if the first pointer holds the value, then what you do is using some kind of temp, you hold on to the first node, then make the first node point to its link, and then delete the pointer. All right. Now let's say that instead you check the last list, and the last holds the value to be deleted. So you start pointer pointing at first, and then you slowly move down the list until you're at the second to last link. So this link holds a pointer to last. So what we do is we delete last, then we make last point to the pointer, then we make this point to null. Does everyone understand so far deleting the first node and deleting the last node? All right. So let's say the node is somewhere in the middle. Let's say, for example, this is the node you want to delete. So we start at first, and then as we move through, we say, does the next node hold the value we want to delete? And if it doesn't, we move down the list to the next node. And then we check again, does the next node hold the value we want to delete? Well, now it does. So we'll create a temp. We make temp point to the node we want to delete. Then we make pointer point to the next for temp. And then we delete temp. And if this function works, if this delete works, then you want to return. If we loop to the end, if we get all the way here, and we haven't deleted anything, the loop ends, and it should print to the screen that nothing was deleted. Everyone understands so far? All right. So an ordered linked list is different. So an ordered linked list in this example is always lowest to highest. So 0, 2, 30, 'So this linked list should insert things and delete things so that the order is always preserved. So let's say, for example, we wanted to add, well, first let's go over the search. So the search for this is slightly different. So let's say we're looking for 5. We want to know 5 in the list. Well, we can run through the list. We say where it's not there. It's not there. And when we get here, we've already gone, this node is higher than, it's bigger than 5. So it doesn't matter if this is the last node or if this is the third node out of a million nodes. We can stop here when we've hit 30 because we're looking for 5 and we've gone higher than 5. If we continue searching further, if there were a million nodes after this is an ordered list. We're guaranteed 5 is not going to be further on in the list. So for the search, you want to loop while you're not null, and you haven't gone higher than the number that you're trying to search for. Now when you insert, the cases for if it's less than first, that's the same as just creating a new first node. And if it's greater than last, that's the same as adding a new node at the end. Now, if it's somewhere in the middle, let's say we wanted to insert 5, that's a little bit more complicated. So we want to start off by pointing to the first. And you want to loop through each one until the next pointer is higher than where we want to go. So if we're at a node that's too small, like 2, that's too small. 5 would be after 2. But the link after it is too big, that means 5 needs to go here. So once we're pointing here, we create a new node. I place 5 there. Then we make 5. Point here. And then we move this so that it now points to this new node. So we have literally added a chain in the middle of the link that preserves the order of smallest to largest number. Does everyone understand this so far? All right. Now, deleting is very much the same. You check if it's first. So deleting the first node and deleting the last node are the exact same as when you are deleting it for an unordered list. But if you're deleting a node in the middle, then it's slightly different. So let's say I pick delete 30. I want to remove 30 from the list. All right, so start off pointing here, and you want to make sure that the next node is the node that we want to delete. So we say, all right, is the next node the node we want to delete? All right, no. So point to the next node. Is the next node the one we want to delete? No. So point to the next node. Is the next node the node you want to delete? No. So point to the next node. Is the next node the node you want to delete? Well, so something I forgot to mention. So each time I point to a node, we say, all right, point to a node. Is this node too high? Is this node greater than the value that we want to delete? Because if the current node we're at is greater than 30, then we should just stop, because the node is not in the list, because this is an ordered list. And if the current node we're at is greater than the value we want to delete, then it doesn't matter if there's 1 or 1 million after this. It's not in the list. So we say, is the current node equal to greater than the value we want to delete? No. All right, well, is the next node the value we want to delete? No. All right, is the current node too big? No. Is the next node the right value? Not either. All right, so point to the next node. All right, is the current node too big? No. Is the next node the value we want to delete? No. All right. All right, is the current node too big? Yes. We've hit 40 and we want to delete 30. We've absolutely passed the point where the node we're looking for is going to be in the list. So at this point, we would just, the loop would terminate, and it would say the item's not in the list. And if you find the item in the list, that's the exact same as deleting it in an unordered list. So let's say, for example, we want to delete 10. If you want to delete 10, say, all right. Hold this pointer, point that to there, and then delete this. Does everyone understand? Any questions about anything I've said so far? All right. So that is it for the explanation for the assignment. I'll be available until 4 to help anyone with any questions they have, or any tickets, or in DMs or anything. Have a nice day, and I'll upload this video when I sometime after office hours.